Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is static and kinematic indeterminacies. So, in this static and kinematic indeterminacies, first we are understanding where we are using, what is meant by indeterminacy, what is the difference between static and kinematic. These are the things which we are going to understand in this particular topic. So, in any structure that is indeterminate means if the number of unknown, what kind of reactions, based on the reactions they may be getting based on their end support, depends upon the which kind of support we are providing for that element. For example, we are considering beam or any truss, plane members, 3D trusses, in space, frames. Various different types of elements are involved in at the time of construction of structures. In that, we have to, at the time of analyzing these structures, we have to understand what kind of behavior of that particular element. So, the combination of elements is nothing but a structure. So, in this structures, based on the type of the support, for example, we have different supports: roller support, hinged support. This is roller, this is hinged, fixed. Like this, various supports, various different types of supports are involved at the time of construction or at the time of various beams. For example, this is the cantilever beam. This is called as cantilever. One end is fixed and other end is free and simply supported. Both are hinged, or one is roller, other one is hinged. So, hinged under the combination of roller. This type is known as simply supported beams. Like this, we are understanding the various loading conditions also there. According to the loading conditions, the reactions and the internal forces we are understanding. So, whether it is maybe point load, for example, in simply supported, otherwise continuous beams. Two or more supports involved in that, such type of beams are known as continuous beams. So, in this simply supported beams, point load, uniformly distribute, any type of loading condition, whether it is fixed, one end is fixed or both end fixed, such types of beams are known as fixed beams. So, point load at any point, concentrated loads, uniformly distributed loads, uniformly varyingly distributed load from midpoint to the variation is different from mid to uniformly varying distribution, from one end is high to low. These are the loading conditions. And maybe from free end to high, like this, various kinds of loading conditions which we are going to understand in the elements. Loading conditions. So, based on the type of the support, loading conditions not only for beam, trusses, frames. So, these are various types of structures. So, based on the type of structure, type of element, types of element, support and loading conditions, and continuation of continuation of the particular structure, whether it is mixed with any other kind of structures and what kind of material we are using. These are all the parameters which are involved in these for unknown reactions, and also the are the internal forces for understanding the structure. So in that once we understand these internal forces and also the number of unknown reactions or internal forces exceeds the number of independent equilibrium equations. So in these independent equilibrium equations, available. In most of the cases, that is 3. In most of the cases, that is 3. That is 3. So in this 3, so for know about the unknowns present in that particular structure, so those equilibrium equations are not enough for identify the unknowns. Such is known as indeterminate structures. So this is nothing but the statically indeterminate. In other words, what it cannot be solved solely using the equations of static equilibrium. So those are forces. So these equilibrium equations, what we are going to understand from these equilibrium equations is, so what kind of forces? All forces which are involved along the x direction, the sum of forces along x direction is equal to 0. This is the one of the condition we understand in equilibrium equation. This is the one of the equilibrium equations. Similarly, all forces along the y direction, the sum of all along y direction, the sum of all forces is equal to 0. The momentum with respect to the other direction, that is x, z, here we consider the sum of all movements which are involved in that. So these are the static equilibrium equations. So in these equations are not enough for understanding, for or consider for analysis of structure, for conducting the process, for understanding the elements which are present in that particular structure. Such is known as statically indeterminacy. So this is nothing but the static indeterminacy. So a structure is statically indeterminate if the number of unknown reactions or internal forces exceeds the number of independent equilibrium equations available. In other words, it cannot be solved solely using these equations of static equilibrium equation. So these 3 equations are not enough for understanding or for analyze the structure. Such type is known as. So these static equilibrium equations are not enough. Such a structure is known as the statically indeterminate structure. So kinematic indeterminacy. A structure is kinematically indeterminate if the number of unknown displacements in previous statical indeterminacy reactions and internal forces are involved. So in static equilibrium equations, reactions as well as internal forces plays a role in the statical indeterminacy. So in this, a structure is kinematically, this is comes under the static equilibrium equations. So whenever the coming to the kinematic indeterminacies, the number of unknown displacements exceed the number of independent kinematic boundary conditions. So such indeterminacy of structures is known as kinematic indeterminacy. So in static, it depends upon the reactions as well as the internal forces. So coming to the kinematic indeterminacy, what are the various displacements? Those are exceeds the number of indeterminate kinematic boundary conditions. In this, kinematic indeterminacy is related to the rigidity of the structure. Rigidity of the structure. A more rigid structure will have fewer independent displacements. So whenever that flexibility is there, so the independent displacements are more. So that exceeds the number of independent kinematic boundary conditions. Such structures are known as kinematically indeterminate. So in this, whenever the known parameters are not enough for finding the or identify the unknowns which are present in any structural elements, or at the time of analysis of structures, those known parameters are not enough for understanding about the various characteristics and properties which are involved in the structural element. Such kind of structures are known as indeterminate structures. In that too, again, we are going to categorize. Depends upon the reactions based on the loading conditions, the type of end, what kind of support is there. So according to that, we are understanding the various reactions and their internal forces. Such type is known as statically indeterminate structure. So coming to the displacements. So the kinematic boundary conditions have their own independent numbers. So the number of independent kinematic boundary conditions are not enough for know about the displacement of the particular structure. Such type is known as kinematic indeterminacy. So kinematic indeterminacy is related to the rigidity. So when it is more rigid, the displacements are very less. If the structure is flexibilities are more, the kinematic indeterminacy, the displacements are more. The value of the kinematic indeterminacy is also more, because the independent kinematic boundary conditions are not enough for identify the unknown displacements in those structural elements. So here, for determining the indeterminacies, we have different methods. Those are, for finding the degree of static indeterminacy, using reactions is one of the method. So first we are going to understand the how many reactions are there. So in that, the first method we are choose based on the using reactions. So the number of unknown reactions, it depends upon the type of support. Each support has their own kind of number of reactions. So fixed support has their reactions. hinged has their reactions, roller has their own different kinds of reactions. It depends upon the type of supports. It depends on the type of support. So in this, the number of unknown reactions we are finding from along the reaction along the x-axis, the reactions along the x-axis, the reactions along the y-axis, and the reactions along the z-axis at each support, at each and every support. It depends upon the how many number of supports are there. So like that we are going to count the number of unknown reactions. So now subtract the number of independent equilibrium equations. So here generally it is 3 for 2D structures and 6 for 3D structures. So it belongs to two-dimensional structure. Generally the independent equilibrium equations is equal to 3. The independent equilibrium equations for two-dimensional structure is equal to 3, and the independent equilibrium equations for 3D structures, that is equal to 6. So the independent equilibrium equations for 3D structure is equal to 6. So this, how many, for finding the degree of static indeterminacies depends upon these parameters. Now the formula is, so number of unknown reactions so the formula degree of static indeterminacy is equal to number of unknown reactions. The number of unknown reactions depends on the type of support. And number of independent equilibrium equations. It depends upon the type of, whether it belongs to 2D structure it is equal to 3, 3D structure it is equal to 6. This is the one of the method for identifying the degree of static indeterminacy. Using members. The second method is using members. In using members, so in this using members for beams and frames, degree of static indeterminacy is equal to m minus 2j is the formula for beams and frames. So here where m is the number of members and j is the number of joints. Using this formula, we are going to identify the degree of static indeterminacy for beams as well as the frames. So how many numbers are there? For example, like this, which we consider fixed support or hinged support. How many members are there in that frame? Or otherwise in that particular beam, like that, the numbers minus joints. How many joints are there? Like that, we are understanding the formula and we identify the degree of static indeterminacy. For trusses. So this is for beams and frames. Now move on to the trusses. For trusses, so degree of static indeterminacy is equal to m minus 2j plus 3. This is the formula for identify the degree of static indeterminacy using members. So using members as well as using reactions, we may identify the degree of static indeterminacy. This is for trusses. Here m is equal to number of members, J is equal to number of joints. Like we are going to identify the degree of static indeterminacy. So now the degree of kinematic indeterminacy using displacements is one of the method. Using releases is one another method for identify the degree of kinematic indeterminacy. So using displacements counts the number of unknown displacements, horizontal, vertical and rotational displacements at each joint. So the condition of the joint plays a role how many displacements we will get. So based on the condition of the joint, we are understanding the unknown displacement present in that particular structure. So subtract the number of independent kinematic boundary conditions. So fixed supports, rollers, etc. So according to that, based on the boundary conditions, we are going to subtract. So this is the formula for this degree of kinematic indeterminacy. Number of unknown displacements minus number of independent kinematic boundary conditions. Now method 2, this is the one of the method using the displacement we are going to identify the degree of kinematic indeterminacy. Now move on to other method, that is equal to using releases. So count the number of releases required to make the structure statically determinate. So that is nothing but the degree of kinematic indeterminacy is equal to number of releases. So how many number of releases are required? It equal to the static determinacy. That is nothing but the degree of kinematic indeterminacy. So here we understand the one beam, consider one fixed beam. Both ends are fixed. It's a beam, both ends are fixed. Both ends are fixed, it is a simple one. So the number of reactions. Like this. So at fixed, these are the reactions which we are going to understand. And here also 3. X-axis, Y-axis and the rotation. So movement like that. So the number of reactions at fixed end is equal to 3. The unknown reactions is equal to 3. And at both are fixed ends. So that's why here the number of unknown reactions is equal to 3 into 2. 2 fixed supports are there. So 3. 6. The number of independent equilibrium equations, it is a 2D structure. So it is a 2D structure. So the number of independent equilibrium equations, 6 minus 3 is equal to 3. Here we use this reactions method. So we know the number of unknown reactions is equal to 3 plus 3 minus number of independent is equal to 3. 6 minus 3 is equal to 3. For beams we may m minus 2j also. So here we have, so it depends upon the number of members and number of joints. According to that we are going to identify the formula also. Here only one it is there, that's why simply we are understanding like this. So how many number of members, like this also we may find out based on the any kind of method. So it is a simple fixed beam with supports. So that's why we are understanding the static degree of static indeterminacy is equal to 3 for this given condition. For fixed support, number of reactions. So the number of reaction 3, how we'll said. So the reaction at joint, any joint, for example, C is a joint, at joint, consider C as a joint. So now Rx is the reaction at joint. Reaction at joint C in X direction. Similarly, RCY is nothing but the reaction at joint C in Y direction. Y direction. This is equal to MCZ is the moment at joint C about Z direction. About Z direction. So similarly, the displacements what we understand for this fixed support. So the displacement in X direction at joint C is 0. So for fixed support along the X direction, there is no displacement that is equal to 0. Displacement in Y direction at C is equal to 0. So the number of reactions is equal to 3. There is no displacement for this fixed support. For fixed support, the member may, whatever it may be the member, whether it is beam, truss, whatever it may be, fixed support. For fixed support, number of reactions is equal to 3. So the reaction at any joint, whether it is A, B, whenever it is there, so the reaction along the X direction, along the Y direction, and also the movement is also there in another direction, that is equal to Z. You may consider X, Y, Z in different ways also. So the reactions may be in YZ direction, movement in X direction. It depends upon the axis, the axes we are considering. So the displacement, coming to the displacement point of view, in this, the fixed support, the displacement in X and displacement in Y directions is equal to, there is no displacement for this fixed support. And the reaction about Z direction is also 0. So the rotation is also 0. So for these are the parameters what we understand for this fixed support, because for identifying the degree of static indeterminacy as well as the degree of kinematic indeterminacy, the type of support plays a role for getting the number of reactions and how many unknowns are left, how many compactability equations or other methods are required for analyzing the structure. It depends upon the type of support. So here for fixed support, the number of reactions is equal to 3. There is no displacement and also the rotation about the Z direction at that particular joint. In hinged, coming to the hinged, now we will understand. So the number of reactions is equal to 2 only. So in any case, any structure, in that structure, once we understand the fixed and we changed it as a hinged, the analysis is going to change, because the fixed has the number of reactions is equal to 3. The hinged has the number of reactions is equal to 2. So the analysis and the static indeterminacies, kinematic indeterminacies, the support plays a major role for understanding and getting the numerical value, for analyzing the structure. So these are the parameters we have to be very careful about these joints. So for example, these supports. So fixed support, number of reactions is equal to 3, because in X and Y directions, reactions is there as well as movement is there. So like that we have to understand. So it's the basics are very, very important. Then analyzing the structures is in the correct align. So like that, now in this the number of reactions in this, the reactions in the hinged support. So Rx is there, Ry is equal to there. But there is no movement in hinged support. Hinged or pinned support. Similarly, the displacement in x direction at a joint is 0. There is no displacement in along the x and y direction. But here understand, here there is no point of movement. So here there is no point of movement is 0 along the z direction in the hinged support. But here rotation about z direction at a joint is not 0. So if reaction is there, displacement is not there. If reaction is there, displacement is not there. Movement is not there and rotation is there. Like this, we have understand all these 6 parameters for various supports. Now consider, once we understand these 6 parameters for this reactions along any direction, generally we consider x and y, and movement along z, displacement along x, along y, and rotation. If it is there means it is not there. If it is not there means it is there. Like that, vice versa, we have to understand these conditions. So this gives the better understanding about the structure, and it is minimize the work for understanding the analysis of the structure. So for hinged supports, the number of reactions is 2. Along the x direction as well as the y direction, there is no movement. And also that coming to the displacement, so along the x direction and y direction, there is no displacement, but rotation about z axis is there in hinged supports. Roller support, here the number of reaction is equal to 1. So the reaction at joint y is the direction. It means displacement x direction is there, not there. Along x direction is not 0, because here what we understand, reaction, we will check. For roller support, reaction along x-axis, reaction along y-axis, and movement z-axis. Displacement along x-axis, displacement along y-axis, and rotation. Here the number of reaction is equal to 1 for roller support. Like this, we are considered the roller support. So reaction along x-axis is not there, mean displacement along x direction is there. So rotation along the y direction is there. So displacement along the y direction is not there. Movement along the z direction is not there. Rotation is there. Like that, we are understanding the various parameters which are involved in this for understanding the analysis of structures. So here the 3 important majorly used supports are fixed support having the number of reactions is equal to 3, hinged support is equal to 2, roller support is equal to 1. So the roller support, the reaction only in terms of y direction. So here x and y, here x, y along the z rotation is there, the movement is there. Coming to the displacement in kinematic, so there is no displacement and displacement is there, but rotation is there. Displacement along x-axis and rotation is also there. Like this, we are understanding the things finally, XYZ, XYZ, XYZ. So like that, we have to understand the reactions. So these are helpful for better understanding about the structures. So in vertical guided roller support, so it is a vertically moving one. So like this, the support is different. So it is a vertical. So the number of reactions is equal to roller support, the number of reactions is equal to 2. So reaction at joint A in X direction and also movement is also there. So like this, we are understanding the various parameters which are involved, how we are understanding those supports, and based on the loading conditions, these reactions and the displacement, that gives the better idea for analyzing the structures. So this is the static and kinematic indeterminacies about the as a part of the analysis of structures. Thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.